Today's lesson. What we're going to do now is we're going to talk about similar triangles. Now, one of the things you should realize is the following. So I'm just going to highlight what you need. What you need to know is that when you talk about these things called congruent figures, we're talking about congruent shapes. And they have exactly the same size. Now, what else you need to know is that when they have the same size, they also have the same shape, but then they also have the same angles if they are the same size and shape. That's the one thing that basically ties these things together. Now, when you talk about similar figures, here's what you need to know. When we talk about similar figures, we say that they have the same shape, but the key concept is that they have different sizes. But what you need to remember is that even though they have the same shape, right, and they're different sizes, they still share the same angles. Now, the big concept of the day is this. Triangles can be proven to be similar if the interior angles are identical or their side lengths are identical. Now, when you hear the concept of side lengths, what you're thinking about, what you should be thinking about is ratios. And so what we are doing is we're literally comparing the sides of either the big triangle to the small triangle or the small triangle over the big triangle as a fraction. And what we'll see is that all of the collected sides, their ratios, end up being the same. Let's go and take a look at that right now. So right now we have some preliminaries. We have to take a moment and we have to label our triangle. So if I have a triangle, let's call it A, B, and C, with this other triangle D in it. So you'll notice we have, if you look at it, overall, there's two triangles here. We have the first one by ADB, which is this. And we have another triangle. Let's call it BDC. Okay. Now, if I was taking a look at these triangles, let's just go over this again. So there's our triangle. We have our two sides. We have our triangle labeled as this. So this is triangle BDC. Now, when we go and describe that side, if we want to describe the angle, we do this. We call it angle BDC, where angle B is in the center of D and C. So we start here, go up here, and then go down to represent that angle. And now let's go on to our triangles, because we're going to use some of the stuff that we studied before to do it all. So let's go and prove similarity between interior angles of a triangle. So remember, we have to have our triangles being identical. Now, I'm just going to quickly draw what my triangle looks like here. My triangle for this thing has two different triangles. We have the big triangle, and we're going to call that A, B, C. And the little mini-me triangle, we're going to call triangle D, E, C. Now, I like looking at these triangles as separate to each other. And by doing so, it allows me to come up with some serious insights. So remember, we have to have all of the angles of this triangle having to match this triangle in order to say that they are similar. Okay, so now let's go through proving that something is similar. So if I'm taking a look at BAC, so if I take a look at BAC, it's the same as angle. If I take a look at BAC, which is this, from here to here, okay, you'll notice something. And I'm going to take a moment, I'm going to highlight that for you. I'm going to tell you that angle, that triangle, that angle BAC is equal to angle BDC. And the reason why that is true is because of the F pattern that happens here and here. So we have this, we have those two X's being identical. Okay? And we justify it by writing the fact that we have an F pattern here. And now moving on, you'll notice for part 2. Part 2, we're going to take a look at triangle ABC. Angle ABC is the same as angle DEC. And I would tell you right away we have another F pattern for that. Because if you think about it, these two sections, those two lines are parallel because of these two 90-degree angles. So essentially, those two 90 degrees are identical. You can either say that you have both at 90 degrees, or you could say we're using the F pattern. So now we need to relate the final angle of this triangle. And if you take a look at this latest triangle, both angles share angle C. Now, since we have all three sides, all three angles being the same, we would say the following. Angle ABC is similar to angle DEC. And we say that little squiggle sign means it is similar. And so now, let's take a look at the next problem. The next problem is dealing with this big ugly thing here. Now that big ugly thing has two parallel sides. Now, if I look at this first problem, the first problem set is if I take a look at angle FGH. So if I take a look at FGH, it's going to equal something else because of a Z pattern. And just remember that only works for two parallel lines. So if I was looking at FGH, that's this thing right here. Now if I click, basically if I think about it, that means angle G and angle J are the same. So we have the following. We have angle FGH is the same as angle JGH, and that's because of the Z pattern. Now, we have another Z pattern occurring in here. That second Z pattern looks like this. Now that second Z pattern looks like that. So now our angle is going to be based on F and K. So when we write this out, we're going to have this going down. So we're going to have our second angle in our triangles to be GFH is the same as angle JKH. And finally, if you think about it, our last side here, angle H, which is the point H, which is shared between both triangles, has basically the opposite angles that allow it to be the same. Now, at the end, all you have to do is you're just going to say that the following is true. That FGH is similar to JKH. Now let's move on to the rest of the lesson for the day. Now when we do this next lesson, it's all about proving the pair of triangles is similar by actually comparing their lengths. So another way to do this is to actually compare them. So in this case, what we're going to do is I'm going to highlight. I always look at these two triangles and I always try to find the same similar side. So I always look for the smallest side. In this case, the smallest side in the big triangle is 15, and the smallest side in this triangle is 6. The line segment for this side is going to be this, WU, and then the small side triangle, its line segment is called XZ, and that's why it's on the bottom of this fraction. And then all I do is I write their two ratios. So now I got 15 over 6, and that gives us a simplified result of 5 over 2. Now the key is we're going to go and compare all the bigger sides. Notice this time I'm using big over the small version of my triangles. So I'm relating the big sides to the small sides for both. Now we're going to go take a look at the next biggest side. We've taken a look at the smallest side. Now we're going to look at the next biggest side. The next biggest side looks like this. It's going to be UV. Now when I take a look at UV, the next biggest side after 6 is 8. So I'm going to go and compare it to XY or YX. It doesn't matter what you put there. Both of them are the same. Both line segments are the same. And then when you calculate, you're going to get 20 over 8, which ends up being 5 over 2. Oh, that looks interesting. That looks similar. That looks very interesting. So now let's go and take a look at the biggest side. In this case, we're going to have this WV over YZ, which is equal to 30 over 12, which gives us our final answer of, you guessed it, 5 over 2. And then we simply say our triangle WUV is similar to triangle XYZ because the ratios are the same. And we're good. Now, I would tell you, go back to example A and assume the triangles are similar. What I want you to do now is I want you to set up the equivalent ratios to determine the unknown side lengths. Let's do that for this next problem. So, we said the following of our triangle. We said triangle ABC is similar to triangle DEC. So, that means I'm actually going to do something like this. I'm going to work big divided by small as my ratio. And so now you're going to say the following. AB over DE for the first one is going to equal to, well, this big side here compared to this little side here. So what we're going to get is BC over EC, which is the same as our hypotenuse now, which is AC over DC. And all you're going to do is you're going to pick any two of these. So either these two or these two or this and this equaled to each other to allow you to solve for anything you need. So now, if we assume this next problem here, these next two triangles, FGH and JHK, are similar, then what do you need to do is you need to take a moment and label them. So I'm going to label the opposite side. So these two are the same because they're opposites, right? Now these two are going to be the same because of the Z pattern that's formed here. So let me just quickly show you that. All right, there it is. There's our Z pattern. We're good to go. Now, once we've done that, you need to recognize that, and you label all the corners. And I'm also going to label this last corner here. And here is our Z pattern that goes with that. It goes like this. Oh, oh. So our angle is going to be right there. Now, in order to do this next problem, what we need to do is we need to just go with the flow. We use these visual cues of the X's, the O's, and the dots to help us figure out what our lengths are going to be. So the first one, I'm going to go and use FG, FG, F to G, which means it's going to be K to J for my matching side. And now for my next one, let's go and take a look at GH. So GH is dot zero, right? So JH is another dot zero in the other triangle. So it's GH over HJ or JH. Both work. And now we have our final side to do, which is going to be FH, which is X naught. So I've got to look for X naught on my little triangle. And so we have this ratio. So remember, we're going to take any two of those. And that's it. We're done for the day, I think. In order to determine which parts of these next triangles are similar, imagine that the sides are the same, but we need to figure out which angles are the same. What you do is you need to compare matching angles. So I'm going to use my smallest side here. There's my smallest side. Sorry, that's my smallest side on my one triangle. That's my smallest side on my other triangle. Now I'm going to take a look at the other triangle. I'm going to label it. I'm going to use a little red color for the second biggest side, or blue for the second biggest side. And I'm going to do the same for this one. So that means, in this case, that basically WUV, angle WUV is equal to angle YXZ for this one. And you follow that same pattern over and over for the rest of them. I'm just going to pause it and show you the solution. And you'll notice now I'm actually just going to check off U and X on my triangle because I know that I'm done with them. So now we're going to do the next sides. So I've highlighted the second biggest sides on both triangles. And now what we're going to do is we're going to go and use the biggest side on this triangle, on the bigger triangle. Now, the only reason I do this is because I'm a visual person, so it helps me out. So in this case, we've got the following as our solution. Angle WVX is the same as angle XYZ. And like before, I'm going to take a moment and I'm going to check off my angles that I've used. So it's the last angle that's left to do. And all I got to do is just look at that last angle. To get that last angle, I'm going to use angle UWV is equal to angle, it could be angle XZY, and we're done. Now that only happens because these two triangles are similar. Now the big idea for today is all congruent figures have identical sizes and shapes. Congruent means same, identical. It's a twin. Now, when we talk about similar triangles, this is what you need to know. And the ratios of their matching sides are equal. And the interior angles are equal for similar triangles. That's all we got her out of today. All right, so do your homework, which is on this page, these questions. I want everybody to complete the extra challenge.